Applications of Kirchhoff voltage law and Kirchhoff current law. There are 4 problems given, basic problems, so that we can thoroughly understand the Kirchhoff current law and Kirchhoff voltage law. First problem, find the change in voltage. Delta V is equal to change in voltage across AB, that is A and B means change in potential between point A and point B. So we can write it delta V is equal to VA minus VB. This is what we have to find out. See, first problem, the circuit is like this. That is point A, this is a battery here, there is a resistance here, this is point B, and the current is flowing this way. I is equal to 2 ampere. This is resistor is equal to 2 ohm, and the potential here difference is 5 volt. So this is point A. We have to find out point A and B. Let us assume we move this way. When we move this way, this is the movement. See, current is flowing this way to here to here. It means it is counted current, higher potential, lower potential is counted only for resistor. See, here since we are moving, current is flowing, this will be at higher potential, this will be at lower potential. And this is battery negative side, this is battery positive side. And we are moving this way because we have to find out VA minus VB. It means we are moving this way. It means first we are coming, what is the potential here, what is the voltage here. See, we have seen already algebraic sum of voltage across a closed loop A to B is equal to 0. It means what is the voltage here? Voltage is nothing but the EMF of the battery. So here we move from here to here. This is positive side of the battery, positive, and positive side of the battery E. Again plus, and we are moving from here to here. This is at higher potential, this is at lower potential, and we are moving this way, negative to positive. The voltage will be negative I into R. That's all, because there is a battery, there is a resistor. Here this is, if you are moving this way, positive side terminal will be positive EMF, and we are moving this way, this is negative to positive means negative voltage. So this is equal to 5 volt plus minus, what is the current flowing? 2 ampere. 2 ampere into resistance 2 is equal to 5 minus 4 is equal to 1 volt. It means VA minus VB, that is delta potential difference across VA and VB is equal to 1 volt. That is VA minus VB is equal to 1 volt. It means VA is equal to 1 volt plus VB. That implies VA is greater than VB because VB plus 1 volt is equal to VA. So it means delta V is equal to 1 volt here. Second problem, there is a battery here. This is a resistor. This is side B. Current is flowing here. 1 ampere current is flowing. This is equal to 5 ohm. This is 10 volt. 10 volt. And this is point A and this is point B. We have to find out change in potential across A and B. VA minus VB. So we have to find out VA minus VB. First, let us move from here to here. Move. You can move in any way direction, but let us move because since we have to find a potential across VA and VB, let us move this way. It means this is positive, this is negative. And since the current is this way, this is at higher potential, this is at lower potential, then only the current will flow from higher potential to lower potential, higher potential, lower potential, and we are moving this way. So when we move this way, voltage, what is this? Algebraic sum of voltage KVL is equal to 0. This from here to here, see, sigma, this will be positive because we are moving positive negative, plus, and the current is this way, and we are moving this way from negative to positive, that is minus I. I is equal to I into R is equal to VA minus VB, or VA minus VB is equal to this particular EMF is equal to 10 volt plus 10 plus minus I is equal to 1 into 5 is equal to, this will be minus, this will be negative, this will be negative portion, plus into minus, plus into minus, minus 10 minus 5, 10 minus 5 is equal to 5 volt. That means VA minus VB is equal to 5 volt. It means VA is equal to 5 plus VB. It means VA is at higher potential. Third problem, the circuit is like this. It is given potential at point B is equal to 0 volt. This is 2 volt and this is 1.5 ohm, and this is current is flowing this way 2 ampere, and this is point A. Change in potential across A and B. We have to find out change in potential across A and B. Let us move this way, because we have to find out A to B, so we will move this way only. This is the direction move. We move from here, there is a resistance and the current is flowing this way. This will be at higher potential, this will be at lower potential. Since current is flowing from higher to lower potential, this is a battery, this is a negative terminal, this is positive terminal of the battery. Since we are moving this way is equal to, this is positive voltage, drop is equal to I into R. I is equal to 2 ampere, I is equal to 2 ampere into R is equal to 1.5, that is 3.2. This is the voltage drop across this resistor due to the 2 ampere current. This will be minus because we are moving from negative to positive is equal to 2, is equal to 3 minus 2 is equal to 1 volt. That is delta V, that is potential difference across minus VA, VB is equal to 1 volt. In this problem, so this is equal to 1 volt. It means clearly understood VA is equal to 1 plus VB. It means VA is at higher potential than VB, because VB plus 1 is equal to VA. Definitely it will be bigger. Fourth problem. In the fourth problem, the circuit is given like this. B, the current is flowing is 2 ampere. It means series 2 ampere will current flow through this resistor. This is 1.5 ohm. This is 2.5 ohm, and this is at a point A and this is point B. We have to find out delta V is equal to VA minus VB. Let us move this way. This way. It means since current is flowing from here to here, this is at positive potential, this is at negative potential, and current is flowing this way, this is positive potential, this is negative potential, this is negative side of the battery, positive side of the battery. So VA minus VB, we are moving this way. It means when we move from here, here what is voltage drop is equal to plus to minus, it means plus I into R plus here plus I into, because positive negative we are moving, I into R1 we can say R2 plus this is we are moving negative to positive of the battery, it means negative of V. This is the voltage. So therefore VA minus VB is equal to I into R1. I is 2 ampere, R1 is equal to 2 into 3 by 2 plus I is equal to, since series, so 2 ampere will flow here into resistance is 5 by 2 minus battery. What is the battery? 4 volt. This is 4 volt. So minus 4 is the VA minus VB is equal to 3 plus 5 minus 4. 3 plus 5 minus 4. 5 plus 8 is equal to 4 volt. VA minus VB. It means VA is equal to 4 plus VB. So VA is equal to 4 plus VB. It means here VA is greater than VB. It is nothing but VA is equal to VB plus 4 volt. It means VA will be obviously great. So we have to remember one thing is there, whether you move from this direction or this direction, the problem will give the same answer. Let us check up the first problem. In the first problem, let us move in the opposite direction. First problem, let us see the first problem. This way, this is the battery. B, this is 2 ohm, this problem. This is A, this is 5 volt. The current is flowing in this direction. It means first we have to mark this one. This will be positive, this will be negative because it is battery. And the current is flowing this way. I is equal to 2 ampere from here to here. It means this is at higher potential, this is at lower potential. Assume we move this way. We want to know delta V, which is equal to VA minus VB. Since now we are moving from B to A, that is VB minus VA, because we are moving potential B to potential A. So this will become VB minus VA. From here to here it is higher potential, lower. So into I is equal to 2 ampere, R is equal to 2 plus. What is voltage? From negative to positive we are moving, minus 5. This is VA minus, that is 4 minus 5 is equal to minus 1 volt. That is VB minus VA is equal to minus 1 volt, or multiplying VB minus VB multiplying by this one, this will be BK, or VA minus VB is equal to 1 volt. You proceed in any direction, the result will come same. Every book will give different method, but you follow this trace. Follow one single method which is convenient to you. Don't confuse, don't follow all the method, you will get confused, because here we assume that if you go from higher potential, lower potential, that is as a positive voltage. Lower potential to higher potential, it's a negative. Battery, irrespective of, we are moving any direction, positive terminal means positive EMF, negative to positive terminal means a negative EMF. So follow one single method. Whether you change, whether you move this way or move this way, VA minus VB will comes definitely 1 ohm. So need to worry about it, follow one single method.